Okay, so in our previous class, we already looked at what is material balance, what is mass balance or material balance. It is the law of conservation of mass leading to what is called material balance. So I've already asked you a few examples where you can actually do material balance in your home. Okay, if you have tried it, very good. If you haven't tried it, you are more than welcome to try it. Okay, so again, we have a few words that I was using yesterday. The first one is the word system here, and the second one is the law of conservation of mass. So these are the two important things in our material balance class. So first of all, we look at what is a system. Okay, whenever we are doing material balance, mass balance, energy balance problem, we'll always refer to a system. So first of all, we have to understand what is a system. Okay, so system is just an arbitrary portion of or a whole process that you want to consider for analysis. So system can be anything that you want to analyze. Okay, so for example, system can be a stirrer, can be a condenser, can be a reactor, bioreactor, mixer, boiler, or the whole oil refinery itself. Okay, and other unit operations found within the industrial sphere of human activities. So basically, system is whatever you want to analyze. Okay, and system can have open or closed system. So for closed system is a system where changes occurs in the system, but no mass exchange occur within the surrounding. So if you have a system, you'll have a surrounding. So for example, let's say if I just draw a square here, okay, and I say this is my system. So this is my system, and everything around it, this whole around here is called my surrounding. If I have a closed system, everything that is happening here is happening inside the system. Nothing is happening, nothing is occurring within the surrounding. Okay, so that's why we say for a closed system, input equal to 0, output equal to 0. So everything is already in your system. Okay, it's already in your, whatever you want to put in your system is already in your system. Yes, you are not adding anything or you are not removing anything until you are done with the system. If you have an open system, a system where materials or mass crosses the boundary of the system. So if I have an arrow, so if I put here, there's an input and there is an output. This is my input, okay, and this is my output. So automatically, if you have something like this, it becomes an open system. Okay, so that is the difference between open and closed system. Next one is that if you have open and closed system, we have a few process classification on how the material crosses the boundary. The first one, we call it as batch processes or batch system, where no mass crosses the system boundary while the system is being observed. So here, while the system is being observed. So as example just now, if you have a system and you have already put everything in your system, and when you are observing the system during that time where there is no input and there is no output, you are not putting anything in, you are not taking out anything, so the process is known as batch process. Okay, so feed is added before the observation starts. So whatever, let's say you have a pot, okay, so you put your water, you put your vegetables, you put your meat, you put your rice or whatever in the system, okay, and then you start, you observe the system. So this system is considered a closed system because during the time you are observing the system, you are not putting anything into the system anymore. Everything is already there. Feed is added before the observation starts. And then after, let's say, 1 hour or 2 hours, you are done using the system. Then only you remove the content of the vessel. So after 2 hours, then only you open the lid. You open the lid of the system here, and then you take out everything that you put in. So that is how a batch system works. Okay. So Then if you have a batch system, you have a continuous system. So for continuous system, as its name, continuously you are adding something and continuously you are removing something. So there will always be input and there will always be output. Okay, so one of the example in your house is your, let's say, your shower head. Okay, your shower head. So water is coming out from your shower head, right? And this is your pipe, right? So water is continuously flowing from your shower head and going out to your body. So water, as long as you are opening the pipe, water is flowing in into the shower head and going out through the holes in your shower head. So the system here is your shower head system. Water is flowing in and flowing out. So this is what we call a continuous process. Okay. And then we have another process which is in the middle of batch and continuous process, which is known as a semi-batch processes. Meaning that you can have, let's say, this is your system again. You can only have input but no output. So only one thing is coming in, nothing is coming out. That is called a semi-batch process. Or you can have system again, nothing is coming in but something is coming out. There's no input but there is output. So that's why it's either has an input or output. And there's a special type of semi-batch called fat batch. Fat batch meaning that it's a semi-batch with a only input. Okay, so those are the three classification of processes. Do you have any questions so far or everything okay? Okay, if no questions, then we can move on. Okay, so I'm still using, yes, okay.
For the batch process, right, the mass crosses the boundaries means there's only a change of mass in the system and not the surroundings, right?
Yes.
Okay, okay. Thank you, Doctor.
Okay, so basically for batch system, everything you have to put before you start the observation. Once you start the observation, there should not be anything input or anything output. Okay? Any other questions? Okay, so this is the image, the process flow diagram I showed you yesterday that we are trying to solve, where we have the recycle, we have the bypass, we have the reaction and everything inside here. So here, as I mentioned, system can be anything, right? So if you look at here, definitely this thing is an open system because we have input coming in and coming out. And this is a open continuous system. But then which one can be classified as a system? So for me, I can say that just the reactor is the system for me, because if let's say I only want to know what is happening to the reactor, so I can say that this is a system for me. Or I can say that I just want to know what is happening to the condenser. So this is also a system, because system is something you want to analyze and you put your boundary based on what you want to analyze. Or I want to analyze the whole thing, so this whole thing can be a system. So it depends on what you want to analyze. Okay, so if you just want to see the reactor, then your reactor is a system. If you want to see the whole process, then the whole process is a system. If you, let's say, you want to just see here, this part here is your mixing, so you just focus on this one. This mixing point can be also your system. If let's say you have this part, this is a separation unit because one is going here, one is going here. So this is also a system. So it depends on which system you are looking at. Okay. So if you have a system, if you have a batch system, if you have a continuous system, if you have a semi-batch system, the system can be in steady state or unsteady state. Okay. Steady state, if you are talking about steady state system, the condition inside the process remains unchanged with time. Okay, the condition of the flowing stream remain constant with time. So meaning that, so the condition here can be temperature, pressure, mass flow rate and everything. Flow condition is input and output. Okay, so meaning that if you look at here, initially you have 1000 kilo of water inside. Let's say this is your boiler. Okay, so you are putting in 100 kilogram of water per minute into the system. So this is your input, right? So we can see here this is an open system, and this is an open system. So this is, we have input and output. This is a continuous system. So when we're talking about steady state system, there is no accumulation inside your system here. So initially you have 1000. You start with having 1000 kilo of water. You are putting in 100 kg of water, but you are also removing 100 kg of water. So whatever water you are putting in, the same amount of water you are putting out. So there is no accumulation in the system. The level of water will always remain 1000. Doesn't matter you look at it at t equal to 1 minute or t equal to 1 hour. That's why it's saying that the condition of the flowing stream remain constant with time. In our case here is our flow rate. So the flow rate does not affect the quantity of mass in the system. So that is steady state system. If you have steady state system, you must also have unsteady state system. So for unsteady state system is the other way around from the steady state system, meaning that there will be accumulation in your system. So the same example, you have starting with 1500 kg of water, you are adding in 1000 input as 1000 kg of water per minute, but you are only removing 90 kilo of water per minute, meaning that there is a difference between 10 kg of water per minute, meaning that you are adding 100 but you are removing 90, meaning that every minute 10 kg of water will be accumulated in the system, meaning that there will be a change in your final in the volume of your tank here. So at t equal to 0, your mass is 1500, right, kg. If I say t equal to 1 minute, so after 1 minute I've added 100 kilo of water, but the same minute I've removed 90 kilo of water. So I can say that at t 1 minute I have 1510 kg. So meaning that the condition, okay, the condition inside the process changes with time, right? Because at time 0 it's 1500, at time 1 minute it's 1510. So this is how we define our unsteady state process. So this is another example where you have here small amount of input and large amount of output. Okay, so those are the difference between unsteady state and steady state process. So for steady state process, your process can only be continuous. Okay, if it's a batch process, it won't be steady state. So for unsteady state process, it can be continuous, it can be batch, or it can be semi-batch. Okay, for steady state, it can only be continuous. There is no unsteady state batch process or unsteady state semi-batch process. Okay, so those are the systems that we are looking at. So if I were to recap, we have open system, we have closed system. You need to understand what are the definition between open system and closed system. You have batch process or batch system, continuous process or continuous system, and then you have semi-batch process or system. You have to understand what is the definition of those processes, and then you have steady state and unsteady state system. Okay, so those are the things that you need to understand, because these are the things that you will need to use in order to solve material balance problems. Okay, so just for example, okay, this is for example for you to try to see whether you understand or not whether the process is open or closed, steady state and steady state, continuous or batch. So example number one is that I have a tire. Okay, I have a car tire and I'm filling it with air. Okay, so if you look at, first of all, we define our system. What is my system? My system is the tire. This is my system. Okay, this is the system that I want to analyze. So I have a tire. Tire is being filled with air. So I know there is an input. So if there is input, definitely it's an open system because there is something going into the system or passing the boundary layer of the system. So I know this is an open system. The next thing I want to know is that whether it's a batch, continuous or semi-batch process. So if I look at here, I only have one going in. Nothing is coming out. So I know that this is a semi-batch because it has either input or output. So I only have my input here, no output. So this is a semi-batch process. Now I want to know whether it's steady state or unsteady state. So I know that initially there will be less air in the tire. After a while, let's say I put here 1 kg per minute. Okay, I'm pumping 1 kg per minute of air into my tire. Initially, I have less air in the tire. After 1 minute, I'll have more. After 2 minutes, I'll have even more until my tire is filled. So I know that the volume or the pressure of the tire is changing with time, meaning that it is an unsteady state process. Okay, so this is the answer. Okay, so you have material crossing the system boundary, so it's an open system. You have only input, no output, so it's a semi-batch process. The pressure or volume changes with time, so it is an unsteady state process. Okay, so how about a bottle of cold juice left on the table? So what do you think? Whether it is a steady state, unsteady state, open system or closed system, or is it a batch or semi-batch or continuous system? Anyone would like to have a guess? Open, semi-batch, unsteady state. Okay, anybody else? I have one answer here. Your friend is saying that it's open system, semi-batch process and unsteady state system. Okay, anybody else would like to try? You can always unmute your mic and talk to me. Steady state. Okay. Anybody else? So I know how do you come up with open system, semi-batch system? Okay. Anybody else? It's okay, you can try. It's better you try now rather than you fail in your test or in your final exam. Closed system, open system, semi-batch, unsteady state, closed system, closed, steady state, closed system, semi-batch, steady state. Anyone else? Semi-batch, closed, open, semi-batch, steady state. Closed system, semi-steady. Unsteady state. Open system, semi-batch, unsteady state. Okay, so let's see what is the answer. Okay, so it's a closed system, it's a batch process, and it's an unsteady state system. So why we say it's a closed system? For those who have said that it is a closed system, so why did you say that it is a closed system? Let's say you have a bottle. Okay, this is your. Let's say this is your bottle. No input. Okay, if it's a closed system, there is no input and no output, because I'm just saying that the bottle of cold juice is left on the table. So I just put this one on the table. There's nothing coming in, nothing going out. So it's a closed system, right? Because no input, no output. And then I say that no input, no output. Okay, material does not cross the boundary because there's nothing coming in, nothing coming out. So it's a closed system. Because of no input, no output, it's a batch system, right? But temperature changes with time, right? If you remember from a previous slide, I said that the condition can be your mass flow rate, your volumetric flow rate, your temperature, your pressure, your volume, your mass. So if you have a cold juice bottle, you take it out from the fridge, you put it on the table, you know that temperature in the fridge is lower than temperature on the table. So definitely after a while, after let's say 10 minutes, 20 minutes, they will always, the temperature will be different. Instead of having a cold juice in the bottle, you have a room temperature juice in the bottle. So that's why it is an unsteady state process. Okay, so one more example. Water flowing through a smooth pipe with a fixed diameter. So again, open or closed system. If it's a thermos bottle, will the situation change? Okay, if it's a thermos bottle, the situation can still change, because if it's a thermos bottle, even though the purpose of a thermos is to maintain the temperature of your liquid in the thermos, but after a while, there will still be a temperature reduction. Okay, even if it's a thermos bottle. Okay, did I answer your question? Okay. Anything else? Any other questions? If no, then try to solve for example number 3 here. Water flowing through a smooth pipe of a fixed diameter. Is it an open or closed system? Is it a continuous batch or semi-batch, or is it steady state or unsteady state? What do you think? Open system, continuous, steady state. Open system, semi-batch, continuous, semi-batch. Open system, continuous, steady state. Open, continuous, unsteady. Open, continuous, steady. Okay, so you have a pipe, right? You have a pipe. Water is flowing in and water is coming out. The diameter at the entrance here is same as the diameter at the entrance at the outlet. That's why I said fixed diameter. Okay, so material crosses the system boundary. Yes, because your system is your pipe, right? This is your system. This is the thing that I want to analyze. So it is going in and this is coming out. So it's an open system. Input and output. So this should be, oh, why is it semi-batch? It should be continuous. This is wrong. Okay, this is a continuous process because there is no accumulation in the pipe. It should be continuous. Okay, and then no changes with time. Okay, there's no change in volume, there's no change in temperature, there's no change in mass. So this is a steady state process. Okay, so this should be continuous, not semi-batch. This is continuous. Okay, so one more for you to ponder. Okay, I'm not going to give you an answer. This is something for you to decide on your own. I've given you flush tank in a toilet. Depending on the time of the observation, the system can be an open or closed system, a batch, semi-batch, or a continuous process, a steady state, or an unsteady state system. So try to come out with a system, okay, with a situation where, let's say this is your flush, okay, this is your pipe going to your toilet, and this is a pipe filling up the flush. So try to come up with a situation when your system will be an open system, when your system will be a closed system, when your system is a batch system, when your system is a semi-batch system, and when is your system a continuous process, and when is it steady state, and when is it unsteady state. Anyone want to have a guess? Let's say when your system will be an open system, continuous and steady state. What situation will have this one? Closed system when there is no water filling in. Okay, try to give me the answer for this one. When will your system be an open system, a continuous process, and a steady state system? When will it happen? When you press the flush. Okay, during flushing. So what happened during flushing? Okay, so when you, let's say this is your the flush nozzle here. So when you pull down, right, water will start flowing out, going to a toilet, and then at the same time water will start coming in, right? So you have water coming in, water coming out. That is your open system. Since there is no accumulation, right, there is no accumulation, so if it's coming in and coming out, it's a continuous process, right? If there is no accumulation, then there will be a steady state process. Okay, so you can work out when is the system. So that is for our open system, continuous process, and steady state. What if I want my system to be closed and batch? Unsteady state, so it can only be closed and batch. Okay, so when is it closed and batch and unsteady state? So when is it closed and batch? When all the water has accumulated in the tank. After flushing water in the tank. Okay, everybody agree with that? How about when water full in the tank, right? When we just have a tank, there's already water. You're not doing anything to the tank. So during your time observation, this is a batch and closed system because nothing is coming in and nothing is going out. If let's say I do another example. Okay, I've flush again. This is my pipe going in and this is my pipe going out. This is my nozzle. So now I have flushed it and then no more water is coming out from here. Only water is coming in to the system. So what is this process? Only water coming in. Is it a closed or open system? A semi-batch. Okay, very good. Open or close? Open system. Very good. Steady state or unsteady state? Unsteady state. Okay, so it's an open system, semi-batch because there is only one input, no output, and is also steady state because water will be accumulating in your system. Okay, so you can find more examples of how to define your system is open system, closed system, steady state, unsteady state, batch, continuous, or semi-batch. Okay, I hope you understand this concept. Okay, if you have any questions, you can ask. No problem, we can still discuss about it. Anyone have any examples of an closed batch system? Can you give an example? So if I ask you, try to make an open, steady state, and continuous system. So what example can you give from your daily life? Okay, we are just talking about whatever you see in your house, outside your house, whenever surrounding your house. What can have an open system can what? Okay, give me an example for open system, steady state, continuous. Cooking food using periuk while cooking. Okay, so while cooking, what is your process? While using the pipe watering the flower. Okay, that can be accepted, right? Because you have same amount coming in, same amount going out, no accumulation in the pipe. It's an open system. It's a continuous and steady state system. Okay, very good. I don't understand what you mean cooking food using a periuk. What is that system? If you're cooking food using a periuk, is it an open or closed system? What if we are cooking a Maggi? Everybody eat Maggi here? Yeah, everybody likes to eat Maggi. Okay. Since you are not here yet, if you were here in the campus, most of you will be eating Maggi all the time. Since you are at home, so you have other choices. So let's say you are cooking a Maggi. I don't know how you cook a Maggi, but this is how usually I cook it. I have water first in my my periuk. Then I add in the Maggi, right? Let's say this is my Maggi. I add in the Maggi, and then I add in, let's say I add some vegetables, I add some egg. What else to add? And lastly I add the packet. Okay, the perencah, right? So is this system an open system? Yes, it's an open system. Is it a batch, semi-batch, or continuous system? Semi-batch. Why? Because why is it a semi-batch? I have input, right? I putting in a lot of material into my water. Is it a steady state or unsteady state? Unsteady state. Why? Temperature, okay. Temperature of water is changing. Okay. Other than temperature, what is changing? Size of Maggi, volume. Okay. The total mass also changing. Okay. Because my Maggi has a mass, my vegetable has the mass, my egg has a mass. So whatever mass initially of the water, because water will also be losing mass because it will be boiling. So water loses mass. So this thing is you have your unsteady state process. Okay. So I hope you understand what is the difference between all these processes, because it is important when you are using your material balance after this. Okay.